Hello friends, in this video we are going to talk about insertion sort. Insertion sort is one of the sorting algorithms. Let's see how insertion sort compares with other sorting algorithms in respect to time complexity and space complexity. Insertion sort is similar to bubble sort in terms of time complexity and space complexity. Insertion sort best time complexity is n and average is n square and worst case is n square. The best case n comes when the input is already sorted, and the space complexity is constant because we do a in-place swapping of the elements, so no additional space is required for executing this algorithm. Let's dive into the algorithm part. So why the name insertion sort is given? Because the element that you are considering is inserted into the correct place inside the array, which is the reason for naming this algorithm as insertion sort. Insertion sort has two loops: the outer loop, which is to iterate over the array, and the inner loop to compare the elements in the left side of the array. So when you walk through the array, you take the element and then you compare that element with all the elements which is in the left side of that element. So here we are making sure while j is greater than 0 so that we don't run into negative indexes, and then we are making sure that if element is less than list of j, only then we keep iterating towards the left side. If the element is greater than the list of j, then we break the loop and we come out, and then we insert the value of the element into the right index, which is j plus 1, and then return. So we keep doing this until we exhaust the counter, and then at the end of the outer loop we would be able to get a sorted list. Let's take a look at an example. So as I told, we are going to take the first element, not the zeroth element, because zeroth element does not have anything to compare with. So the first element is 3, and then we compare it with the previous element 4, and 3 is smaller than 4. So we are doing a swap here, 3 and then 4. Iteration number 2, 3, 4, 5. So here 3 and 4 are marked in green color to represent that they are a sub-array which is sorted, and 5 to 7 is another sub-array which is unsorted. So all these unsorted elements are going to be considered. So in the unsorted sub-array, the first element is 5. So we are considering that. So when we check 5 and 4, 5 is greater than 4. So we don't need to do any swapping, but add 5 to the sorted array list. So our sorted sub-array list is 3, 4 and 5. And our unsorted sub-array is 2, 6, 1 and 7. In the iteration 3, we are considering the element 2. So we are considering 2 and 5 for comparison, and then 2 is less than 5, so we are doing a swap. And then we are comparing 4 and 2, 2 is smaller, so we do a swap. And then we compare 3 and 2, 2 is smaller, so we do a swap. And now at the end of iteration 3, we have 4 elements in our sorted subarray and 3 elements in our unsorted subarray. In iteration 4, we are considering the element 6, and the element to the left of it is 5, which is smaller, so 6 is greater, so there is no swapping required. So we move on to the next iteration, and now we are considering the element 1 and 6 and 1 is smaller, so we do the swap. 1 and 5, 1 is smaller, we do the swap. 1 and 4, 1 is smaller, we do the swap. 1 and 3, 1 is smaller, we do a swap. 2 and 1 is smaller, so we do a swap. And at the end of iteration 5, we have 6 elements in the sorted list and only 1 element in the unsorted list. So now we are comparing 7 and 6, and 7 is greater than 6, so there is no swapping required, and we add 7 also to the sorted list, and we don't have any more elements in our unsorted list, so that marks the end of all the iterations, and we have the final array list which is sorted 1, 2, 3, 4, 5, 6, 7. Let's take a look at the implementation part in Java. So we are going to have a class called as insertion sort and a method which takes in an input of array of integers, and then we are going to find the size of the array and assign it to the size variable. And then we are having a for loop where we are starting from index as 1 because 0th element does not have any element to compare to, and then that element is assigned to a variable called as element, and then we are going to have j as I minus 1 because we need to compare the previous elements. And while j is greater than 0, to make sure that we don't run into negative indexes, and make sure that element is always less than array of j. We continue this loop until element is less than array of j, and when it is greater we break the loop, come out, and then we give the value to array of j plus 1. And similarly in Python as well, we are having a for loop and a while loop, and we iterate over the element from 1 to the length of the array, and then j equal to I minus 1 because we are comparing the previous elements. And in while j equal to greater than 0 and element less than array of j, we are making sure that we don't run into negative indexes, and we are making sure that element is always less than array of j. When element becomes greater than array of j, we break, and then we come out, have array of j plus 1 equal to element. As we saw in the beginning of the video, the time complexity is O of n square, since we are having a for loop and we are having a nested while loop. So the time complexity becomes O of n square for average case and worst case. And for input which is already sorted, this while loop would not be run at all because the element less than array of j would never become true. So in that case we run only the outer for loop. So which is the reason we have the best case as n and not n square. And that's the end of this video. If you like this video, please subscribe for this channel. If you like to learn more about the other sorting algorithms, then please press the bell button to get notification when I add more videos related to this topic. Thank you.